Okay, well, thank you. Let me start by talking about Proqis. A lot of people don't know about what we do. It's not an airline company, by the way. We are an industrial gases company, and Air Liquide, Air Products are competitors. So we make industrial gases, oxygen, nitrogen, for industrial usage as well as medical use as well. So hospitals and stuff. So some plants that are dedicated to making medical oxygen. 99.9999% oxygen. So, those plants are regulated, by the government to make sure that if there's anything that goes to the human body, we have to make sure it's the right, level of purity and things like that. And so with that, Proqis is actually the biggest industrial gases company in North America, in South America. It's one of the biggest in the world. What we do is very important. We supply most of the industries, whether it's in buildings, the chairs you're sitting on, in one way or the other. Something that we do, if you drink carbonated drinks or whatever, it's something that we make that ends up showing up in the product. So we are everywhere pretty much, very well diversified. But with the way things are going these days, we have to be very competitive in how we do things, right? In air separation processes where we make oxygen and nitrogen, argon, krypton, and things like that. Our raw material is just air, right? We have to compress it, cool it down, and then distill and make the products that our customers want. So it's very easy. The main cost here is power, right? We buy a lot of electric power, millions of dollars. In fact, just in the US alone, sometimes we spend $1 billion in just power costs, right? It's very expensive. We also make hydrogen from natural gas. So we buy a lot of natural gas. Just the group I manage in Houston alone, this year we'll spend close to $400 million if gas stays around $2.50, $3. But if it goes higher, our cost will go up that much. So what I do is to try and lower the cost of production for Proqis. So from a variable cost perspective, it's very important. I used to be in our technology center where I train a lot of people in these types of things. The skill set is a little bit unique in terms of what we do. And so we have to train our own people. Okay, so just to give you a little bit of background, and then I'll go through this a little, quickly. So when I say process systems, this is the real plant operations, right? Unit operations that we're trying to optimize our system. So just to simplify it and to make it a little easier, I will talk about our pipeline business center as one of the groups I manage. But we do have plants in Buffalo, New York area, a central location where we monitor over 300 plants in Puerto Rico, Canada, US, which are pretty much unattended. We have to run these plants remotely. We can start and stop the plant, remotely from places like that. And we've taken out a lot of cost out of our system. We run our plants very lean, and the things we do actually enables us to do that. So one of the reasons I was hired to join Proqis, I used to work for Exxon in Canada, Imperial Oil, was to basically build this system. So I've been involved in this for over 20 years. And now I manage a lot of folks here. So I'm not going to go through the agenda itself, but this is what we do. And I'm going to focus on what we do from, our pipeline business center. Just in the US alone, the area that I have responsibility over, I look after over more than 600 miles of pipeline. A hydrogen pipeline alone along the Texas Gulf Coast is over 300 miles long. We have all these major refineries that we supply hydrogen, we supply oxygen and nitrogen. This is DOT regulated because Department of Transportation for those in the US. So because it's hydrogen, right? If there's any explosion, if there's overpressure and there's an explosion somewhere, it has some implications. So we have to do things very well. There are some rules that we have to follow. And for me, the biggest thing is to make sure our customer is always happy. They are supplied. It doesn't matter if our plant shuts down, one of our plants shuts down, we still have to supply them. They don't even know what happens. And so we have to meet customer expectations. And so number one is to make sure that we run our plant safely. The second thing is to make sure that a customer is supplied, no matter what else is going on. So we have backup systems. We might vaporize liquid and put it in the gaseous form and supply a customer. Or we have hydrogen storage underground, for instance, 2 billion cubic feet of hydrogen that we can supply our customers. So that is what we do, and that is my area of expertise. Just a little picture showing some of our pipeline, some of the field operations. But I have obviously a lot of challenges that I have to deal with as a manager for the group. There's a lot of things that we have to deal with. It becomes a utility system for our customers. Most of the refineries, they tell us what they expect to take, and yet that demand can increase 30% just from one customer, or it can go the other way around. Whilst at the same time, we have to commit to a natural gas supply company at the beginning of each month, tell them we want to buy so much MMBTU of gas every day, and whether you take it or not, you are committed, you have to pay, right? So the variation that goes along with it is a lot of cost that I have to incur, sometimes $60,000 a day, just like that for a couple of plants, is a cost that I have to incur because we don't meet our nominations, right? Or we use more than we expect. Gas prices at the beginning of the month was for Houston Ship Channels around $2.54. Today is $3, right? So that 50 cents or 54 cents, it's a lot, I think 3 or 4 yesterday. That 50 cents delta is a cost that I have to incur, and we have to optimize our system in real time to make sure that we minimize our costs. So variable cost minimization is so important for me. It's not just the cost, but also to be able to calculate how much revenue we're making so that variable margin is optimized. So a lot of challenges, and I'm not going to go through it. You can read all these things. Our plants can shut down, or different things that we have to deal with. But I have to work with a lot of people. So it's a lot of coordination, there's a focus, the teamwork with other groups in order to make sure that our customer is supplied regardless of what else is going on. And that is the key role that my team plays. So the question is, why do we even have to optimize our system? From operations excellence perspective, I want to make sure that we still stay in business, right? So we have to make money. There are times when we actually lose some money, but I have to find other ways to recover it. So at the end of the month, I should know how well we are doing. So we look at our system. I did indicate we have multiple plants, spread across. We make the product, we put it in the pipeline. We have to compress it at a pressure high enough so that it is delivered to the customer at whatever the minimum delivery pressure they expect. So if you want to automate anything or you want to optimize, you have to ask yourself, is it that simple that if it's just, all you do is open a valve and you supply a customer, there's nothing to optimize, just don't worry about it. It's already optimized, right? But if it's a complex system, we have changing conditions, and you have some degrees of freedom to supply. So for example, I said gas price is $3 today versus $2.54 at the beginning of the month. Well, I don't have to run the plant at the maximum rates. If I have storage, I can actually take some product from our storage if it was manufactured at a lower cost. So things like that we have to do in real time to make sure I can supply our customers and ensure that we have a good business to run. And that is what I have to deal with. And just to paint a picture of what it is that we do, typically if you have a plant that is running, the primary control systems, we have control valves that can control pressure, flow, you have temperature control and things like that. So this is what we have. My expertise is actually in the green boxes. I went to grad school to learn how to do these things where you have we have models that actually tell us where the plant should be running. You should be able to predict, once you make a change, any valve moves, I should be able to predict where the process is moving towards. So if I'm going to make off-spec product, I have to make corrections so I don't make that off-spec product. So these are high fidelity, some very good models that we have. And then on top of that, we have to put in an optimization system that actually will have economic optimization to tell you how you need to run the plant, right? And those are the things that we do, and they are the increasing level of difficulty as you move up, this triangle. And not only do we have to do the optimization, there's a lot of data management, data flow that goes back and forth that you have to know, and to be able to calculate some KPIs to tell you where you are in real time as much as you can. If your compression equipment is not working too well, you have to be able to figure it out, so you don't want to incur more cost than you need to. So those are the things that we have to do in general. But to bring it down, specifically, I have a number of plants. All our plants are different. Some of them are byproducts that we actually buy. We may buy hydrogen from an ethylene production plant. So we get hydrogen that may be, let's say, 80% pure, and we put it in some pressure swing adsorption units to actually make 99.99% hydrogen. And then we compress it and put it in our pipeline. Or we build on-purpose plants, plant 1 to plant N, multiple, steam methane reforming plants where we make hydrogen and put it in the pipeline. So the plants that are, we get, byproduct sources from other producers. They become what we call a feed-forward variable. We don't have control over it. Whatever they give us, we put it in the pipeline. But the other ones, we decide how we run the plants, what rates we need. We need to buy natural gas for these plants. So we have all these plants that produce, and we have to put it in the pipeline. Okay, so what happens is, my group, I have a group that does advanced process control. They determine how we run these plants based on some optimization. As the demand changes on our system, we have to adjust production to meet, the demand. You don't want the pressure to build up in our pipeline, or you don't want it to go too low as well. So we have to make a proper adjustments, and that is what we do. And then we put in an optimizer that tells each of these individual advanced process control units where they should be running at what rates, based on the efficiency of each of these individual plants. Every plant is different, like I said. So this is very high level, very detailed analysis that has to be done in order to know where to run these plants. And then finally, we have to now put in an optimization thing that would actually do it in economic optimization that would do that. There are several inputs that we need from different people. As things change in a day, natural gas prices changing. There's a business input. Should we get product from our cavern, or we should just let it stay, or actually make extra product and inject if gas prices are lower than what we had at the beginning of the month, things like that. So a lot of decisions that have to be made in real time. There are operations input. We need to take this plant down today for maintenance. We do X and Y, those things. So we work on things like that, and a lot of different people involved in making sure that we are actually on track and getting the product at the right time and at the right cost, right? So we have to calculate our variable margins. For instance, today we are, let's say, about a week away from the end of the month, and I should have an idea whether we are right on. We'll be making our numbers. We'll make something better than what we had in our forecast, or we are a little bit off. And what do I need to do to make sure that by the end of the month we actually making money? We should be in the black and not in the red. So it's very, very important. So with all that as a background, I just had just one slide to indicate what exactly do we have to do. So number one is to identify the right problem to solve. There are some of these applications we do where we actually minimize variable costs. Some of our oxygen pipeline, it's just all we're doing is compressing the product, and for the most part, it's to control pipeline pressure. So just minimizing costs is the right problem, right, to solve. There are other, on our hydrogen system, we actually have to maximize variable margin. So we have to calculate revenues and also calculate our costs. And then the net is what we are looking at, because there's a lot of interaction between them that you need to know that. So you have to know what you are trying to solve. And so you define the right optimization problem, right? It is not the same solution that fits every instance. And we have different clusters of plants around the country, and we have to know which ones to do at all times, okay? And we have to automate. You know, you take out variability. We have people that run shifts all the time, and we have to make sure that we run these plants to the point where the solution is right, and there's less variability, regardless of which operators actually run in a particular shift. So you take out a lot of variability. So the other thing is to also, whilst you are doing that, a lot of opportunities to maximize value from your digitized resources. Yeah. To maximize value from your resources. I put this chart here that actually shows some of advanced analytics. We show, just looking at this, you see a number of plants. You know, that shows let's say, dollars you are leaving on the table if you are running some equipment inefficiently. It actually ranks them. Engineers will look at this very quickly, and they know how much. We don't just put in a KPI, but we put a dollar value. It's costing you $10,000 a day, $20,000 a day, and kind of rank all of them. So it's a priority on which ones you need to fix. So it's just to show some of the things that we do from a digitalization perspective. So know those things and make sure you actually extract the maximum value. And then once we do these things, we have to support these applications. You don't even bother putting in anything if you have no way of supporting them, right? You can't just do it today and then tomorrow there's nobody there. Somebody quits and there's nobody to support them, right? It's a specialized skill set. So we always have to identify ways to increase value. And like I said, without safety and reliability, forget about optimization, right? We do this as the third thing. But just one slide before I summarize quickly here. It's just a way of what we call operational intelligence. You know, we gather a lot of data from different systems. We have to clean that data, you know, merge them, transform the units, do whatever you want. But that becomes the main, you know, data that is stored for everybody to use, the single source of truth, you know, single version of the truth. So every KPI that anybody uses should be from the clean data, not, you know, data with a lot of bad signals and things like that. And then once you have that, we have a lot of things, applications, outputs that people see globally, everywhere. And we develop tools. So what my group does is to try and make sure that we not only have KPIs, but it provides the right input for people to react very quickly. And our operational intelligence is to ensure that you react very quickly, right? You don't have to wait 2 days or 3 hours. As soon as something happens, somebody should address it very quickly. And that is what we call operations excellence from our books. And that is what I'm judged on. That is what I drive. So from a summary perspective, these are a few things that we have to do. If you're addressing a complex system like that, you have to coordinate with a lot of groups, a lot of different people. You have to use the appropriate tools to optimize the system. Now make sure the data you are using is accurate. Otherwise, you know, if you have bad input, you're going to get, you know, a bad output. And you have to support the system, like I said, to make sure that you have smooth operations all the time. And there should be clear ownership. It doesn't matter what that is. Somebody has to be responsible for each particular KPI, whatever it is you're measuring, so that people can respond to it. So if you send an alert, it goes to the right person, and then they address it. Thank you for your attention. Any questions?
How do you address data quality and data confidence?
Data quality, well, I guess we have, for the most part, we have algorithms that look at, for instance, analyzer inputs, for instance. We have a data integrity that looks at what comes in, what is the maximum value, what should be the minimum value, the rate of change. So you'll be able to put in algorithms that will clean the data. Sometimes it will use the last good value as an example. So a lot of rules to make sure that the data is cleaned before we use it. That's an example.